NASA called these photos a triumph. They released them with press statements about inspiration and a new generation of explorers and humanity's return to the moon. And when I first saw them, I understood why. The resolution is extraordinary. 8,000 pixels of lunar surface rendered with a clarity that makes the moon look close enough to touch. The Shackleton crater at the lunar south pole, rendered in a contrast so sharp that the boundary between the sunlit rim and the permanently shadowed interior looks less like a geological feature and more like a wound that never healed. These photos are genuinely extraordinary, but the longer you look at them, the longer you sit with what they actually show rather than what the press release says they show, the more the triumph narrative starts to develop cracks, because these photos are not just images of a beautiful, desolate landscape. They are a technical document, a record of an environment that the 4 human beings aboard the Artemis 2 spacecraft flew through at 49,000 kilometers per hour while their bodies absorbed radiation, while their suits kept the vacuum from reaching their skin, while the engineering between them and the most hostile surface in the accessible solar system held its margins. When you look at these photos as a technical document rather than an inspiration poster, what they show is not a destination, it is a threat assessment. The Shackleton crater, because the crater is the reason the Artemis program is targeting the lunar south pole in the first place, and because the photos of it reveal something that the mission briefings discuss in careful technical language that most public reporting does not translate into plain terms. The permanently shadowed regions inside Shackleton and the other craters at the lunar south pole have not seen direct sunlight for potentially billions of years. The temperatures inside these shadows, measured by orbital instruments and confirmed by surface probe data, sit at approximately 40 Kelvin, 40 degrees above absolute zero, cold enough that volatile compounds, including water ice that arrived via comet and asteroid impacts over geological timescales, have been preserved rather than sublimated away. This is why the South Pole matters. The water ice confirmed in these permanently shattered regions is the resource that makes a sustained lunar presence economically and logistically viable. Water for drinking, water electrolyzed into hydrogen and oxygen for propellant, water as radiation shielding mass. The presence of water ice at the lunar South Pole is not speculation. It is confirmed by multiple independent instrument packages on multiple orbital platforms. The photos show the surface above these deposits. They show the terrain the Artemis surface missions will need to navigate to reach them, and they show, if you are looking at them as a field geologist rather than a public affairs officer, exactly how difficult and exactly how dangerous that terrain is. The lunar regolith visible in the high-resolution images is not soil in any sense that the word implies familiarity or safety. The texture visible at 8,000 pixel resolution confirms what the Apollo sample analysis established and what every subsequent remote sensing measurement has reinforced. The surface of the moon is covered in a material that has been produced by 4.5 billion years of impact events occurring in the complete absence of the atmospheric and hydrological processes that round and smooth and chemically alter terrestrial sediment. Every grain in the images is the direct product of fracture, angular, sharp-edged, electrostatically charged by continuous solar wind bombardment, sized in the range that penetrates deepest into the respiratory system when inhaled, and chemically reactive at its surface in ways that make it biologically aggressive to soft tissue in a manner that has been compared in the peer-reviewed literature to asbestos exposure. The photos show this material covering every surface in the frame. They show it coating the rims of small craters. They show it accumulated in the low points of the terrain in deposits whose depth is difficult to determine from orbital imagery, but whose extent is total. The Artemis surface crews will be moving through this material. It will coat their suits. It will work its way into every joint and seal and mechanism through the electrostatic attraction that makes lunar dust one of the primary unresolved engineering challenges of the entire program. The photos document the problem. The solutions are still being validated. The shadows in the images deserve more attention than they typically receive in public discussion of the Artemis imagery. On Earth, shadows are temporary. The sun moves, the angle changes, the shadow shifts, and eventually the terrain it covers receives direct illumination. On the moon, in the regions near the poles that the Artemis program is targeting, some shadows are permanent. The geometry of the moon's axial tilt, which at approximately 1.5 degrees is nearly perpendicular relative to the plane of its orbit, means that the sun never rises more than 1.5 degrees above the horizon at the poles. Craters with walls high enough to block this near-horizon sun create interiors that are in permanent shadow. Permanently, not seasonally, not for geological epochs. Permanently, for as long as the crater has existed in its current form. The interior of Shackleton crater has not seen direct sunlight for perhaps 3 billion years. The images show this shadow as a hard geometric edge where the sunlit rim meets the interior darkness. Instruments can measure temperature and volatile content inside these shadows by indirect means. Cameras cannot image inside them with visible light because there is no visible light there. The darkness in these images is not a photographic artifact. It is the real absence of photons in a region that has been lightless for longer than complex life has existed on Earth. When the Artemis crews descend into these regions to access the water ice deposits, they will be working in artificial illumination inside a darkness that predates the evolution of the human visual system by billions of years. The photos show exactly where that darkness begins. The edge is sharp and it does not move. Now consider what the photos do not show. The radiation environment that the crew of Artemis 2 flew through during the lunar flyby is invisible to any optical instrument. The cosmic ray flux passing through the capsule hull and through the crew members' bodies at a rate that their dosimeters were recording continuously cannot be imaged. The solar energetic particle environment that the current solar maximum is generating at elevated intensity relative to any Apollo mission is not visible in an 8,000 pixel image of the lunar surface. The Van Allen radiation belts that the crew passed through twice, once on the outbound trajectory and once on the return, are not in the frame. The photos show the surface of the moon with extraordinary clarity. They do not show the environment between the surface and the crew. That environment is documented in the mission's radiation exposure records, in the dosimetry data that will be published in the post-mission health assessments, in the blood sample analyses that will measure the biological response to the radiation exposure the crew accumulated over 10 days in deep space. The photos are the visible record. The dosimetry is the invisible record. Both are part of what the mission documented. The press releases discuss the photos. The post-mission medical literature will discuss the dosimetry. The gap between those two conversations is where the real technical audit of what the crew experienced lives. The far side pass is the portion of the mission that the photos from the flyby make most vivid, and that the mission timeline makes most stark in terms of what it required of the crew and the hardware. During the period when the Orion capsule passed behind the moon and the moon's mass blocked all direct radio communication with Earth, the crew was operating in a communication blackout that lasted between 30 and 50 minutes, depending on the specific trajectory. Not a degraded communication link, not a high-latency connection, no connection. The deep space network antennas that had been tracking the capsule continuously since departure were receiving nothing. The mission controllers at Johnson Space Center were monitoring the last known telemetry state of the vehicle and waiting. The crew inside the capsule was executing their observation schedule, operating their cameras and science instruments, managing the capsule systems, and doing it all without the ability to report anomalies, request guidance, or confirm that their planned actions were consistent with what the ground teams would recommend given current system states. The autonomy that the Farside Pass required of the crew is not a capacity gap that training fills completely. It is a fundamental constraint of the mission geometry that places the crew in a position where they are the entirety of the decision-making capacity available to the mission for the duration of the blackout. The photos taken during the Farside Pass are the product of that autonomous operation. They are images taken by 4 people who were, at the moment of acquisition, the farthest from help than any human beings who had ever existed. The faces in the mission photos are worth examining as carefully as the lunar surface photos, not to look for signs of undisclosed biological harm, which is not what the images show, but to look for what sustained deep space exposure actually does to human faces in ways that the physiology of the environment predicts and the photos confirm. Fluid redistribution in microgravity produces the characteristic facial puffiness that astronauts experience within hours of entering weightlessness, as the fluid that gravity normally pools in the lower body redistributes toward the upper body and head in the absence of the gravitational gradient. 10 days of this redistribution is visible in comparison photos taken before launch and during the mission. The eyes of crew members who have been in microgravity for extended periods show the effects of the intracranial pressure changes that fluid redistribution produces, a phenomenon that NASA's Human Research Program has been studying intensively because in longer duration missions, the intracranial pressure elevation can produce visual impairment and structural changes in the optic nerve that persist after return to Earth. The skin tone changes visible in long-duration spaceflight photography reflect the cardiovascular adaptations of the body to the microgravity environment. None of this is concealed information. All of it is published in NASA's Human Research Program documentation and in the peer-reviewed literature on spaceflight. The faces in the photos show people who have been in space for 10 days. The physiology of 10 days in space is documented and measurable and